Hey guys, welcome to more Maths with Mouth. If you're finding these videos useful and you haven't already, then please do get subscribed to the channel. Also, don't forget to give this video a cheeky little like and share around with your friends. I love hearing from you guys, so please do leave a comment letting me know how you're getting on, and if you have any requests, then leave me a comment. Without further ado, let's get cracking. Guys, this is part 3 of the June 2017 AQA paper 2F. So, we're doing the last few questions and we'll finish the paper. Its calculator, its foundation, a link to the AQA website is in the description below. We're starting at question 21, so let's get cracking. So, Eva thinks she can save water by having a shower instead of a bath. Her shower issues 10.8 litres per minute and it lasts for 8 minutes. She assumes that the water in her bath takes this shape of this solid down here, so it's a cuboid, so it's measuring 110 centimetres by 50 by 35. We're told that 1000 centimetres cubed is equal to 1 litre. Using Eva's assumptions, we want to work out how many litres of water she saves by having a shower instead of a bath. So we need to work out the volume she uses for the shower, work out the volume she uses in the bath, find the difference between the two. So let's do the shower first, so I'll call that VS. So we're told a shower issues 10.8 litres every minute and lasts for 8 minutes. So we need to do 8 times 10.8. And your calculator will tell you that that is equal to 86.4 litres. So that's how many litres a shower is going to use. Next, we need to do the bath. So we first of all need to find the volume in centimetres cubed. So the volume of a bath is going to be 110 times 50 times 35 centimetres. Again, work that into your calculators and that gives us 192,500 centimetres cubed. So that works out the volume in centimetres cubed. We know that every 1,000 of that is a litre. So we then do 192,500 divided by 1,000 to turn it into litres, and we get 192.5. So, to work out finally the number of litres she saves, we want to do 192.5 minus 86.4. which gives us 106.1 litres. Jobs again. Okay, then for part B, diagram A shows the water level in the bath before Eva gets in, and then diagram B shows us the cuboid from part A inside of the bath. We want to answer what effect does this have on the amount of water saved. So we can clearly see that the cuboid fits inside of the bath and it's actually smaller than it. So what we've done in part A, we've had a lower estimate of the amount of water in the bath, which means in reality more water is going to be saved Okay, question 22, we want to work out the side of this right-angled triangle marked X. So, what lovely rule do we know with right-angled triangles when it comes to finding lengths? Pythagoras. If we know two lengths, we can work out the third one. So, if we label our triangle A, B, and C, Pythagoras tells us A squared plus B squared equals C squared. Lovely. If we're trying to work out C, here though we want B, so we take A squared away, we get B squared is C squared minus A squared. So if we plonk our numbers in, we get B squared is 64 minus 9, so B squared is 55, and then finally square root, we get B equals root 55, which I guess I'd probably go to two decimal places, 7.42. Jobs again. Okay, question 23, we want to draw a distance time graph. So for this, we're going to need good old speed, distance, time. So Lily goes on a car journey. For the first 30 minutes, her average speed is 40 miles per hour. She then stops for 15 minutes. She then completes the rest of the journey at an average speed of 60 miles per hour. The total journey time is 1 hour, and we want to put this on a distance time graph down here. So what we're going to do is talk about each part of her journey separately, plot it, and then we'll build up as we go. So the first part tells us that for the first 30 minutes she travels at 40 miles per hour. So we need to work out what her distance is in that first part of her journey. So speed is distance over time. We can multiply by time to get speed times time is distance. So in the first part of her journey, 30 minutes is half an hour, so we want to do 1/2 times the speed, which is 40, so that's going to give us 20 miles. So that gives us our first point to plot, which is going to be 30 minutes along the bottom, 20 minutes up the side. So we plot that point and draw a straight line from 0, 0 to it. So it will look like this. Okay, so we've got our point plotted at 30 along the bottom and 20 up the side, and then we've drawn a straight line from 0, 0 to this point. Okay, then for the next part of her journey, she stops completely for 15 minutes. So she's not going to get any further away, but more time is going to have passed. So the next point that we want to plot is 15 minutes on from 30 minutes. So that's going to be 45 minutes, but we're still going to be at 20 miles. And that will look like this. Okay, so that green line is our next point on our graph. So the last bit now is that we're then told she completes her journey at an average speed of 60 miles per hour, and we are also told that the total journey time is 60 minutes. At the moment we have travelled for 45 minutes, so there's 15 minutes left, and we need to know how far she's going to travel in 15 minutes at 60 miles per hour. Remember, there are 60 minutes in an hour. If we're going at 60 miles an hour, we are going 1 mile a minute. So in this final part of her journey, she's going another 15 miles. So at the moment we're at 20 miles. So we want to plot the point. We're going to be 15 minutes on. So that's going to be at 60 minutes. And we've gone 15 miles further. So we will be at 35 miles. So that's the point we want to plot, which is going to look something like this. Okay, there's our completed distance time graph. If you've got something that looks like that, well done. Okay, then part B asks us to write down the average speed for the total journey. So remember, speed is distance over time. So speed is distance over time. We know that we have gone 35 miles and it's been in 1 hour. So our speed is 35 miles per hour. Jobs are good 'un. Okay, question 24. So the pie chart shows information about voters in an election. So you've got this lovely pie chart here. And we're told 3,360 more women voted than men. We want to work out the total number of voters. So, probably quite a tricky one. If we zoom in, the men have an angle of 110 degrees. Remember, angles around a point add up to 360. So the first thing we can do here is work out the angle for the women. So 360 minus 110 is 250. So the women had an angle of 250 degrees. Now we're told that 3,360 more women voted than men. So if we now work out by how much the women's angle is bigger, we will know what angle represents 3,360 people. From that, we can work out the total number of voters. So, if we do 300, then no we don't. If we do 250 minus 110, that's going to give us 140 degrees. So that tells us how much bigger in degrees the women's sector is than the men's. We know that 3,360 more women voted, so 140 degrees is 3,360. So we can then, from this, if we divide both sides by 14, we would get down to 10 degrees is equal to, now work that in your calculator. Okay, so we get for that 240 people. So every 10 degrees in the pie chart represents 240 people. There are 36 lots of 10 in 360. So the final thing we need to do is 36 times 240, and that gives us 8,640 people. Jobs are good. Okay, question 25. So these are fun probability algebra and tables. So the table shows some information about some CDs. So we've got 2 rock, X pop, and 2 X plus 5 jars. So a CD is chosen at random. The probability that it is rock is 1/20th. We want to work out the probability it is jars. So first important part, the key to starting this question is that we're told the probability it is rock. is 1/20th. Now, that means that 1/20th of all these CDs are rock. So if we have 2 rock CDs, that is 1/20th of the total. So we can say the total over 20 is 2, and then multiply by 20, we get the total number of CDs is 2 times 20, so we've got 40. Personally, I think if you've only got 2 rock CDs out of 40, you're doing something wrong. It should all be rock. Okay, so now what do we know then? Well, we know we've got 40 CDs. We know 2 of them are rock. So we know how many of the others are either jazz or pop. It's going to be 40 minus 2, which is 38. Now, algebraically, we know that we've got x pop and 2x plus 5 jazz. But we know numerically that has to add together to give us 38. So, all of a sudden, we've got ourselves a cheeky little equation to solve. So, on the left, x plus 2x is 3x. So we've got 3x plus 5 is 38. Take away the 5, we've got 3x is 33. And then finally, divide by 3. We know x is equal to 11. So now that we know what x is, we can go back to our table and fill in how many CDs of pop and jazz we actually have. So we've got 11 pop, and then we've got 2 times 11 plus 5 jazz. 2 times 11 is 22, plus 5 is 27. So the question actually wanted, work out the probability it is jazz. Well, we've got 27 jazz CDs out of 40, so it's 27 40ths. Job's a good one. Okay, question 26. So we've got a quadratic with a coordinate table with some missing values that we need to find and then plot the graph. So, first of all then, we need to find the value of y when x is 2. Minus 2. So, when x is minus 2, y will be minus 2 squared. Be very careful when you do these with the negative values, especially if you're using a calculator. Don't put in, so don't do minus 2 squared like that. That's not right. You need to put brackets around the minus 2. Otherwise, you would get minus 4 instead of positive 4. So, we got minus 2 squared, minus 2, but then minus 2 at the end. So, minus 2 squared is positive 4. Minus 2 is add 2. But then we got minus 2 at the end. So, 4 add 2 minus 2 is 4. So, there's our first missing value. Okay, then when x is minus 1, y is minus 1 squared minus 1 minus 2. So, minus 1 squared is positive 1, minus 1 is also plus 1, so we got 2 minus 2, which is 0. So, that's our next missing value. And then finally, we want y when x is positive 2. So, y is 2 squared minus 2 minus 2. So, 2 squared is 4, minus 2 is 2, minus another 2 then is 0. So, there are our missing values. We now need to plot each one and join them up with a freehand curve, and you will get something that looks like this. So, that's our graph. If you got something like that, well done. Job's a good one. In 27, we want to write these numbers in descending order. So, descending order means starting with the biggest and then working our way down. So, first thing I'm going to do here is write this guy in the middle as a normal number. So, 9.56 times 10 to the 3. The decimal point is moving 3 places to the right. So, this is 9,560. So, that is smaller than the guy on the left, 9,563. So, our biggest chap is this 9.56 times 3 to the power of 10. That is saying 9.56 times 3, 10 times, so it's huge. So, that's our biggest. 9.56 times 3 to the power of 10. We can't even write that as a normal number. Then we've got 9,563. And then we've got our 9.56 times 10 to the 3 as our smallest. Jobs are good. Question 28. Rearrange y equals x over 3 plus 9 to make x a subject. So, we're trying to get x on its own from this lovely formula. First thing to do is move this 9. So we do that by subtracting 9. So we get y minus 9 equals x over 3. And then we multiply by 3. So we get 3y minus 27 equals x. Jobs are good. Question 29, we're finally at the end. It felt like this paper went on forever. So, we want to use trigonometry to find this missing length x. So, this is SOHCAHTOA. If you're not happy with SOHCAHTOA, check out my playlist, SOHCAHTOA Trigonometry. Everything you need to know in there. So, we've got this angle of 72 degrees, this length of 8, and this missing length of x. So, the first thing we want to do, label the triangle, label the sides. So, length x is the opposite, and the 8 centimeters is the hypotenuse. Then we go to SOHCAHTOA to work out which bit we need. So, S-O-H, yes it is, because we've got the opposite and the hypotenuse. So, tells us sine theta is the opposite divided by the hypotenuse. Substituting our numbers in, we get sine 72 is the opposite, which is the side we're after, over 8. So then finally, we multiply through by 8, and we get 8 sine 72 is equal to the opposite, which is going to give us a value, if we work it into our calculator, of 7.6. If we go to 1 decimal place, that's our guy. Paper done. Hope you found it useful, guys. Please share it around, get subscribed, give us a thumbs up, give us a comment down below, let us know how you found it. See you in paper 3.